Okay, folks, so good day to you. This copy, once again, is in black and white because that's all my printer does. But this is the core concept that we're going to use to approach the problem that we have next. We're going to describe the transformation of f of x equals x squared, represented by g. And then we're going to graph each function. So what we have here for g of x equals negative 1/2 x squared. So we're going to take our parent function, which is already, let's see, it's already graphed there for you as best as I could. And what we're going to do, we're going to look at what the negative does and also what that half does. Okay, so give me just a second. I want to set something up for you. Okay, folks, so I went ahead and I set it up here. What I want to do is follow the actual directions that's given. I know that we can graph it and then work that way, but we want to make a prediction or a hypothesis about what we think is going to happen based off what we know. So the first thing that I want to focus on, and I'm going to fold the paper so you can see it a little better. We want to look at what the core concept says about reflections. If we have a reflection all the way at the front of our graph, like what we have here in the images, what will happen is our graph will go from opening upward for our parent function to opening downward. So this is going to be our change when, look at that, I can't even graph following the line, when we have a negative in the front. Okay, all the way out front, we reflect across the x-axis. So we go from opening up to opening down. Now, when we have our negative inside the parentheses, okay, so keep in mind what I said. Everything that's outside the parentheses is going to look like a vertical change. So even though what we have here, on the first one, we went from opening up to opening down. Okay, over here we have something happening inside the parentheses, so that's a reflection. But this reflection literally takes the parent function here, y equals x squared, and all that happens, and you can't really see it. Let's say that if this is my right side of the graph, what happens under that reflection is that it becomes the left side of the graph. And as well as the left side of the graph becomes the right side of the graph. Okay, so this case, it would have to be a little bit a reflection across the y-axis, so it kind of mirrors itself over that y-axis. Okay, so what happened here on our given graph, you see we have that negative all the way in the front. There's no set of parentheses here. So what that negative is going to do is going to cause our graph to open downward. Okay, so one thing that we can say about this that we know for a fact is going to happen, and I can write it out. The negative causes a reflection across or in the x-axis. Okay, so that's one of the things that's going to happen here. Okay, and then we have, shucks, I just want to make sure y'all can see it. Then the other thing that happens is that we have a half there. Okay, so you see that half. Now, when we compare the half, okay, I'm going to cover it up for a second. What we have here is, let's see, we have horizontal and we have vertical stretches and shrinks. Now, what I want you to notice here is that that half is not in any parentheses or anything like that. So what that does is that causes us to be on the vertical side. Okay, and then we have, let's see, I really wish this was in color. Okay, so, and I'm sorry about this. So what happened is what we were given was a half x, and so our vertical value here, our a value, and it's going to be between 0 and 1. So what happens is, because we're between 0 and 1, ours being a half, we're going to have a vertical shrink. So what's going to happen is, instead of it going up 2 times as fast, we're going to relax at half the amount of time. Okay, and if that doesn't make sense to you, I encourage you to strongly to go back and look at that warm-up video, okay, because we did some things in decimals, and we can do that again over here. So here we go. So the let's see, how can I say this? The 1/2 causes a vertical, because we want to make sure we have our right term, and it's going to be a vertical shrink or compression. I know I use that word interchangeably. Vertical shrink, I'm going to say like it is here towards the x-axis. So I don't know, maybe I'll say that. So our graph is going to move closer towards the x-axis. I'm going to do that like that because that's how it is in the book. So that's going to be our description of what's happening here, okay? And if you know Miss Gable, then you know I am not the greatest at drawing straight lines, so I choose to do dotted lines if I can. Okay, so now what we're going to do is focus on the graphing part, okay? So here we go. The first thing that I like to do, and I said it before, is that I like to look at what's happening when x is 0. So what I'm going to do is, and I know that this may be kind of self-explanatory at this point. If you feel like you can graph it, go ahead, pause Miss Gable, pick you some numbers, and we can see if we end up with the same or a similar graph, okay? So let's go ahead and do that. All right, so I'm going to let x be 0. So we're going to do g of 0 equals a negative 1/2 times 0 squared. Well, 0 squared is 0, and 0 times anything is 0. So what that lets me know is at the origin, I have a point there at 0, 0. Now what I want to do is I want to look and see. I could do 1, but 1 going to give me a fraction. So let's see what happens at 2, because we're going to divide by 2 in the end. So might as well see what's happening at 2. All right, so I'm going to do, let's see, this right here, g of 0. Was 0. So now I want to do g of 2. All right, so I'm going to do a negative 1/2 times 2 squared. Okay, now already we know it's going to go downward. Okay, and we know that it's going to get narrow. Okay, we're going to do a vertical, get wider. It's going to be a vertical shrink. We're going to let go and relax ourselves. Okay, stretch would be to get narrow, like we're stretching up, we get narrow, we get tense. But a shrink, we let out our breath and we breathe. Okay, and get wider. So here we go. I'm very talkative right now. Excuse me. Negative 1/2 and then 2 squared, because we do our exponent first. It's going to be 4. All right, so we got a negative times a positive, meaning our answer is going to be negative. And if we take 1/2 of 4, or 1/2 times 4, we get 2. So at positive 2, we're going to be at a negative 2. So that's going to be 2 to the right, and then 2 down. So I'm going to get a point right there. Okay, so then let's see here. Oh, shucks. Kind of. Okay, now let's see, what if we look and see what happens at 4. Okay, let's do 4. Let's see, with 4 squared, 16, okay, all right. So here we go, let's do 4. All right, so we're going to do a negative 1/2 times 4 squared. Okay, and so what's going to happen here, I'm going to move this up so you can see a little bit better. We're going to have a negative 1/2. And 4 squared is 16, because that is not 4 times 2. That's 4 squared. 4 times 4 is 16. So we end up with 1/2 of 16 is going to be 8. But we got a negative in the front, so that's going to be a negative 8. So if x is 4, then y is going to be a negative 8. Okay, now, so here we go. I'm going over here, so let's see. 1, 2, 3, 4. And down to 8 will put us somewhere right about here. Okay, now, coincidentally, if I was to put in a negative 2 and a negative 4, I would get that same negative 2 and negative 8. So if I let x be a negative 2, I would get a negative 2. If I let x be a negative 4, I would get a negative 8. Now, while I put these on here, let's see, 1, 2, 4, 8. Okay, the reason being is because we didn't shift this graph to the left or to the right, so it's going to have that same symmetry about the y-axis here. So that is our reason for being able to kind of sort of duplicate those points. And if you got to turn your paper sideways to graph because you like Miss Gable, then hey, you turn your paper sideways because guess what? That's your paper, baby. Can't nobody tell you what to do with your paper if you're trying to graph. All right. And so what happens is, you see here, let me put it where you can see it. That graph reflected across the x-axis, because this is my x-axis right here. So it reflected across the x-axis and it got wider. Okay. All right. Very good. So that is what happens with a vertical shrink as well as a reflection in the x-axis. Okay. So that is example A. I'm going to set up for example B, but I'm going to put that on a different video. Okay. And like I said, if you feel like you mastered this, then you go right ahead and you do your work with no interruption. But if you feel like you have not mastered this after you watch these videos, you better say something. Okay. I'm going to need you to say something, baby. Say something.